everyone, and welcome back to another session in the LCC channel. This is Detlef, and today we are finally going to implement the logic for the signals. We're going to get through that fairly quickly. Prior to doing that, though, let's take a step back and let's walk through the CDI portion of the conditionals descriptions, and all that. Okay, let's pull up the CDI here. Particular node that we're going to configure is 10.01.09. We're going to focus in on this segment called Conditionals and go through each of the elements. Okay, so at the top here you can see the logic. There's actually up to 32 logic blocks that you can go ahead and configure. We're not going to certainly need all that for this simple test layout, but in that you need to kind of think about how you want to use these, right? You can use them any way you want, but you have to decide how and what each block will do. And we're going to go through what each block means in a moment here. Basically, though, what you're going to do is for each signal is pick a certain number of blocks and call that as a group. In other words, say we want to put some logic together through, for a signal, we use logic blocks 1 through 8, and then we'll identify which ones are part of that group, and then at the very end, if it's 8, that's the last one, we'll make that the last part of a group, and then the logic will know to go through those things, and if it finds a condition that's right, it'll jump out and say, all right, this is the last, so I'll go to the next one, 9, and then start scanning through there to find the next group. Okay, little spot for descriptions. Function: is that particular logic block blocked, or is it part of a group, or is it the last part of a group? And notice for the last, it also can be just a single logic block. It's just one case, if it has a yes, no, or an if, or an and, whatever. Excuse me, that's what that function is for. All right, you're going to see the next part here is variable 1 and variable 2. They mirror each other, they match each other. So your choice is what's going to trigger it on a variable change, on a matching event, or nothing. Typically, I just leave this as on a variable change. Okay. What is that source of the trigger? Is it going to be a variable 1 event, or is it going to be one of the track circuits? So we will show track circuits in the next video, but for now we're just simply going to look for an event, basically a sequence of some sort of events that will line up and that'll create a conditional. And then what do we want to associate with that event? It should start looking familiar to you. In the case of this particular module, we're just going to use the 3 choices of stop, approach, or clear or proceed. Okay, and then here's where the actual event is identified. The event to set the variable number 1 true, the event to set it false, and you always need a pair. Even though you're checking for, let's say it's occupied and the switch is in a certain position, you have to put the opposites there just so it keeps track of that. So if it's not occupied and the switch is in the opposite position, you have to put both in there. The V2 side here mirrors that exactly. So exact same setup. And then between the two, you have your choices of logic operation. Okay, you can do V1 and V2, V1 or V2. So if it's V1 has to happen and V2 has to happen, then you get yes, a true action. V1 or either one of the two. V1 XOR V2. What's XOR? It means exclusive OR. So it's either V1 or V2, but it can't be both at the same time. Whereas V1 or V2, it doesn't matter. It could be V1, could be V2, or V1 and V2 both exist at the same time. I've never used these equals or greater than change or equals greater than true, so I'm not exactly sure how to use them. We'll have to learn that, do a separate session on it. And then finally, the conditionals of V1 only, or V2 only, variable 1 only, or variable 2 only. And we're going to use those actually for our signal logic. It's just simply if this condition exists, it says it's a true statement, so it'll issue out its command. Okay, so that's the logic operation between the variables. And then you come to the bottom here. What is the action when true? Okay, so typically you leave these as they are, send and then exit the group. If that's true, you want to send this particular event and then you exit that group and then you look for the next group. If it's false, you just evaluate the next one. But there's choices here. You can send and evaluate the next one. You can exit the group. You can evaluate the next. And with next is kind of neat. If you have a whole bunch of ands, so let's say I wanted event 1 and event 2, and event 3 and event 4, you would use and with next, as well as or with next. Similarly, if it's 1 or 2 or 3 or 4, if any of those events exist, then it would become true. A couple of fun features down here. There's a delay time before action if you wanted to delay it a little bit. A neat function for this would be if, for instance, you have a crossing, and out of the prototype, as soon as that last car of the train clears, it doesn't immediately go back to clear. There's usually a timer that gets set that says after the last car clears the crossing, it may wait 1 minute or 3 minutes or 5 minutes, such that you make sure that the train's entirely clear of the crossing before you reset that signal. So that's what you can do here. There's units of milliseconds, seconds, and minutes. Is it retriggerable? Again, I have not used that one, not exactly sure how to use it, but obviously that has some functionality. And then finally, the action. What is the action that you want to have happen? So you can have up to 4 actions triggered by a particular set of logic. We'll typically just use one. So you can have the action happen immediately, after a delay, immediately if true, immediately if false, delayed if true, and delayed if false. So there's the way that you can create the events. All right, so that's our walkthrough right now.
Okay.
So with this, at this point, now we can finally start putting logic into our node. So I'm going to pull up that crib sheet we made, which is this thing here, relevant associated events. And if this gets to be a little bit more complicated, I would recommend that you first pull together this logic worksheet and really think through all your different logic steps before you start configuring it. Because this module, this little layout, test layout, is pretty simple, frankly, we're just simply going to talk through it, right? There's not a whole lot of magic to the logic here. And so we'll go ahead and just do it straight from this summary sheet that we put together right into the CDI. Okay?
Okay.
So let's go through this. When you develop signal logic, you always go from the most restrictive to the least restrictive. So the most restrictive is obviously if the particular block is occupied, and that should always go to red. And as soon as that happens, we jump all the way out and we get on to the next set of logic, okay? Next group of logic. The other thing I want to do right up front, though, is configure that test case. If the logic errors out, I want to go ahead and put a logic block out there just to make sure that I know that it's kicking out at the right time. So just to give me a little bit of space here, by the way, as we lay out this logic, I really encourage you to leave gaps. Don't try to pack in all your logic one next to the other. Likely you'll find that you need to figure out a step or add a step somewhere in the middle of it. And if you have all your logic steps here packed from one to the end and there's no extra room, well, now you're having to redo the logic, bumping everything out 2 or 3 logic steps. Plus, if you have downstream logic, now you got to move all those.
Wow.
So for this first signal, we're going to go ahead and do the most complex signal first, which goes back to S2EA, which is the double-headed one. I figure we might as well do that one right up front since it's the most complex for our little module. If we decide that that's too much, we can go manually write it out, but I think we'll be okay. For our logic check here, I think we have enough blocks here between logic blocks 1 and 12 for everything else. So I feel fairly comfortable just putting in logic 12. We're going to make that signal to EA logic alert. And basically the idea here is I'm going to put some logic in here. It's the last of the group, the function. It doesn't matter about any of these variables. I'm just going to, let me show you what I'm going to do here. I'm just going to create a logic situation that it will always trigger. So this will be the last of this particular group. We already decided that. I'm not going to mess with, we'll just make it V1 only just to make it simple. Write that. But the whole point is you go down here, action when true, send and exit group. Action when false, send and then exit group. So I'm going to write all these changes. So whether F8 or F9, and it's a totally bogus event, whether those are true or not true, it will send this event. So say send and exit group. So then let's get down here. What action do we want it to send? The action will be immediately we wanted to send this a logic alert, which is basically this logic that we put together here before. Remember, this is what we set up as our little blinky lights. Copy, paste it in here, and I'm just going to save all the changes. So what this does here is the logic alert doesn't matter really the event, whether it's true or false, it will be sending that command and exiting the group. And what is the command? Action 1 immediately will send this O1F7 command. So just for grins, I'm going to go ahead and we saved changes. I always like to reboot the node. Well, let's hold off a minute on that. Instead, let's go ahead and put in the stop conditional, the first stop conditional, so we at least have a couple logic blocks. I'm going to go ahead and just skip the first one in case I decide I want to do something there. Logic 2, I'm going to make it signal 2EA stop OS occupied. In other words, the actual OS section, the switch itself, I'm going to make that the first one. So I'm going to make that the first part of this group, track speed stop. And let's go back to our rules worksheet. Relevant events. Okay, detected OS section. I'm going to just copy this guy here and put it in here. So if this is pasted in, and I know that the not version of that is just one up from there. And we just simply want the variable 1 to be true. So I'm going to write all these changes. So if that OS section is occupied, if the turnout's actually occupied, and only if that's the only thing that I'm going to check on, I immediately want to have that signal go to red. So we can send an exit group. We're going to send the signal occupancy alert, that the event that actually turns the signal to red. And if not, we'll go ahead and evaluate the next one. Okay, so the condition is immediately, as soon as we see, go back to the signal mast, 2EA, right, stop. So that's the signal command I want, the event I want. So as soon as I write that, I paste it in there. I'm going to write all the changes. So we know that from our configuring of the mast rules, the stop will be a red over red with this command. So I just pasted that in here, and the event to set that variable, whoops, up here is 1E, 001E. So I'm going to go ahead and reboot the node, and let's see how it behaves. Okay, back at the layout here, the test layout, we can see that we got our wonky lights going. And if I roll into the OS section, sure enough, it drops to red over red. Now once I clear that, since I haven't got everything else configured, yep, it goes wonky. Turns to red, clears out. Okay, so let's keep going over here. I'm going to group all the different red conditions together. In other words, what are the different situations where we do want to show red over red? So signal 2EA, I'm going to call it being blocked. Now we're going to get into some more discrete logic here. Group that. So what I'm going to look for is if the turnout is thrown to the main, if I'm going from west to east, from left to right, and the switch is thrown to stay on the main, and the next block is occupied.
Okay.
What do I want to do? I want to show a stop. Okay.
Okay.
Variable set true. So first of all, I want to make sure that the turnout, where's my list of relevant events? Here we are. So the turnout is in the normal position. By the way, I had to fix this when I had this these signal commands here for turnouts, these events for the turnouts. I had picked actually the wrong fields from my from the CDI. If you go back, I guess we can just look at it real quick. For the normal and thrown, I had picked down here event 1 and event 2. I really don't want to do that. I want to use the actual commands to throw the turnout. So I moved that from 36, I believe 42 to 30 and 31. Just so you know, so I'm not trying to pull a quick one. All right, so logic 3. So first of all, the switch has to be in the right position, so we're going to say 31, copy, paste, and if it's not true, I'm just going to go ahead and manually do this because it's easier. And so if it's lined for normal, and if the main is occupied, copy, paste. Obviously I can just do this manually a little bit faster. In that case, both of these have to be true. We're going to send and exit the group, and the action will be what? Immediately, we're going to go back to signal to SEA, again put that stop command out there. Now I realize I could probably switch between these different screens on the CDI, but I hope you see that putting this worksheet together, I just copy and paste them, and it's really intuitive at that point.
Yes, indeed.
All right, let's go through another one. Signal to EA siding blocked. And what I'm going to say there is group it, and track speed will be stop. And in this particular case, I'm going to say that, oops, go back to our relevant events. So our turnout is this time thrown to the siding position. And the siding is occupied. So which one's the siding? This guy right here. Exit center group. The action will be immediately. We're going to go back to our master rules. I guess I could have put this in and all at the same time, but this is save all the changes. There we go. So now we've got all the different events that would be the siding being blocked, the main being blocked, and the OS being occupied. All those should show a red. So let's go ahead and test those out. We'll restore. We're going to reboot the unit, and I'm going to go ahead and jump over to the layout, and we'll check that out. All right, this time we're going to test all of our red stop signals. We tested this before, occupancy of the OS section. Now we get off onto the siding, it stays red. I throw the switch, we got our wonky lights again. OS section drops everything to red, and out on the main stays red. Exactly what we want. Conditions now to implement into the logic. One is if the main is clear, and the other one is if the siding is clear, and what do we want to show there. So let's go back to the CDI. I'm going to skip a step, so go to logic 6. I think it's more restrictive to say signal to EA siding clear. Function will not be blocked. It's going to be part of this group. Track speed, this time it's going to be an approach, right? And what's the conditionals for the siding to be clear? Well, we need to know that go back here to my relevant events. We know that we have to be lined for the siding, so it has to be in the thrown position, which is 30. Copy, paste, and I'm going to go ahead and paste it over here for the not condition. And we have to know that this siding is not occupied. Not occupied, unoccupied would be the 07. Copy, paste, and then paste 06 would be occupied. Exit and send group, send and exit group, and that leaves us for the action, and the action will be immediately. And what do we want to use for the siding? Let's go back to our master rules, SE2AA, and I'm going to make it red over yellow, approach slow. We'll just say it's an unbonded siding. So red over yellow will be the condition, and we're going to save all these changes. And let's go ahead and just wrap this up. We're going to go ahead and, so we got logic 6, 7, we'll go to logic 8. signal 2EA, main clear. This will be the highest speed of all the different settings. So the track speed will be clear proceed. And what is the conditions for that? Well, first of all, we need to go back to my relevant events. We need to know that the turnout set to the main, which is 31. I know this is a bit tedious, but let's just walk through it. And we need to know that this the main is not occupied. Unoccupied is 13. So copy that here. Paste. 12 is the opposite event. Send and exit group. Condition immediately. Go back to our mask rules. 2EA clear is the F401 F4. Copy, paste, right. Actually, we're going to write all of them. So this now should cover all of our different logic events, right? Let's open this up a little bit. We're not using this. Stop, the OS is occupied. Stop, the main is blocked. Stop, the siding is blocked. Siding is clear, main is clear, and if it doesn't hit any of those conditions, we get our logic alert.
Okay, let's all give it a try.
So let's go back to the test layout and take a look and see if all these different permutations work. Okay, so here we are at the demo layout. Hopefully all this will work. So we're aligned to the main right now on this switch, and the downstream tracks are unoccupied. So we're on the main. As soon as we hit the OS section, sure enough, it goes into a red over red. And we go into the actual main track. On the next block, it stays red over red, which is what we want. Now let me throw the turnout. Okay, on the turnout, now we're on the siding, which is clear. Should be red over yellow, which is right. Come back. Should reset just fine. Goes back to green. Now I'm going to go back to the turnout. Red over yellow. As we get into the OS section, it drops to red. And we roll out onto the OS. On the next block, the siding stays red, which is what we want. And then throw it back to the main, which is still clear. It works. So those are all our different conditionals. Looks like we got it working. Yay! Okay, with that, hopefully that gives you enough so you can configure your own signals. I'm going to go ahead and finish up the other signals here, and we'll catch you next time when we talk about track circuit.